so this is chapter 2b. I'll just make a video on it, and then like because I'm away for the rest of the week, I think this may benefit a lot of you. So let's just get to it, okay? So this is just a lesson starter right here. So if you just remember the vocab that I taught you in chapter 2a, this should be perfectly easy, okay? So it says here, state the parts of the expression that match these words here. So I've got my expression, which is 5x minus 2xy plus 4a, and it's inside a bracket squared minus 2. So first off, why don't we just expand brackets first, or expand this squared unit first? So this formula will now become 5x minus 2xy plus something minus 2. Now, if you want to figure out what 4a squared is, just remember what's squaring again. You are multiplying something by itself. So in this case, it's whatever's inside the bracket. So it's 4a times 4a. Now, we know that 4 times 4 is 16. And if you remember from previously, if I multiply a by itself, it just becomes a squared. Okay? So this now becomes a squared minus 2. I'll just underline it there. Okay? So what's the pronumeral slash variable combo? So remember, pronumeral slash variable is just the letter, okay? Like the combination of letters that are attached at the end. So in this case, you have x and you have xy, okay? The term, so how many terms are there? There's 1, 2, 3, 4. Terms are pretty much just whatever it is that are separated by minus and a plus sign, okay? So just look how many there are. There's 4 in this case. So you just write that. Coefficients are just the number in front of the pronumeral variables. Okay. So I have the numbers here 5. I have the number here -2, and I have the number here 16. Okay. So those are just the numbers that are directly multiplied to the variables. Constant terms are just numbers that are by themselves, okay? As you can see here, the only number that's by itself is -2. So you would write -2 here. And a squared term is just, you know what squaring is. So I reckon just put in the number in front, or you can put the letter combo. So in this case, it'll be a squared, okay? Now, this was the second half of what I taught you. If I don't think a lot of people got around to doing this, but I'll just go over it again. Basically, all you're doing is you are going to substitute a equals 4 and b equals 5 into their respective positions. Okay, so substitution is the act of replacing a letter with a known number. Okay. So in my first question here, I have 3a plus 2b. Another way of writing this is 3 times a plus 2 times b. But remember, when you see a number directly connected to a pronumeral or variable, it just means timesing, okay? So I'm just visually showing you that, but you don't always write it out like what I've done here, okay? You don't need to do that. What you can do is go to this next line right here. So this is 3, and I'm going to put bracket 4 just to show that I am actually substituting something in. Plus 2, bracket 5, like that. Now, I know this already means times. We know that already. We don't need an indicator anymore. So I can just figure out, oh, what's 3 times 4 then? 3 times 4 is 12. 2 times 5 is 10. And then you just add 12 plus 10 together, which you'll get 22. So that's done. Now we'll try the second one, 6a minus b. Okay? So 6a minus b is 6 bracket 4 minus bracket 5, just like that, close brackets. Okay? So I'm just doing the substituting first. Next thing, I'm going to clean it up. I know this means 6 times 4, and 6 times 4 just equals to 24. And then I'm left with 24 minus 5. 24 minus 5 is 19. Okay? AB plus A. So I have A times B in this case. This is the same thing as A times B. So what I'm going to do, I'm just going to substitute it, but I'll put it inside brackets as well. So A is equal to 4 b is equal to 5 plus 4, just like that. And this means times already. So we know this means 4 times 5 is 20 plus 4. And that just equals to 24. Okay. That's just substituting in a nutshell. So 2b, simplifying algebraic expressions. Okay. Now, the whole goal is to review some of these processes for multiplying and dividing. And you need to understand the word like terms. Okay. And that only like terms can be collected when adding and subtracting. It's just like what you learned previously in surds, yeah? You're collecting like surds, but in this case, in algebra, you are collecting letter combinations that are like pretty much identical to each other, okay? So that's the whole goal for today. So general info read only. So you know from a basic point of view, 2 plus 2 plus 2 plus 2 equals to 8, and anyone can figure it out. Now, just realize this is the same thing as 4 times 2, all right? Now, if we sort of like add algebra to this aspect, yeah, I have 2x plus 2x plus 2x plus 2x, which equals to 8x. But another way was instead of writing 2x plus 2x plus 2x plus 2x, I can just write 4 times 2x, and this means the same thing as 8x as well. So basically, you are just multiplying the numbers in front, 4 times 2, which is 8, okay? So, algebraic expressions. So, the symbols for multiplication and division are not shown in simplified algebraic terms, okay? So we never write the times or the dividing sign whatsoever. What we do is we write it differently. So in multiplication, everything gets combined together, and in division, we change it to a fraction. Okay? So in my example here, I have 5 times A times B. I'm going to smush it together to be 5AB. And we need to recognize that this just means 5 times A times B. Like, that's just without a doubt. Okay? Now, in my second example, it sort of gets a bit tricky, but it's perfectly fine. Okay. So remember, following the rules of BIDMAS, dividing and multiplication happen at the same time. It's not like dividing comes first and then multiplying happens after. You do both at the same time. Now, if both are present, you basically just go from left to right. Okay. So I have negative 7 times x. So that's negative 7x right here. And then I divide it by y squared. So I'm going to put that as a fraction instead. So this fraction line here means divide, and this 7x here means 7 times x. As you can see, I've satisfied all the conditions there, okay? So in my example, so simplify the following, okay? 3 times 2b. So these are just some easy explanations here. Multiply the coefficients. What are coefficients again? They're just the numbers in front. So 3 times 2, which equals to 6b. Now, question 2, negative 2a times 4ab. Okay, so in my explanation here, I have multiplied the coefficient and variable, which in this case is a. Okay, so first let's just multiply the coefficient first. What's negative 2 times 4? And that equals to negative 8, right? And then I have a times b. So I'll just clean this up a bit first. So this will be negative 8 times 8 times a times b. Now, as you can see here, we need to multiply the variable a here. Now, what happens when you multiply a letter by itself? It just becomes squared. Negative 8 times a squared times b. And then you can just clean it up, simplify it all together. You're left with negative 8 a squared b. Now, you don't need to show this, okay? Underline in purple. You could pretty much go from this blue here. You can do that instead, okay? That's all you got to do. So over here is an activity. I'll let you do it yourself. But other than that, you should be fine, okay? So dividing algebraic expressions. Oh, I just got to change this around. So dividing algebraic expressions, okay? So you can cancel common factors. Okay. So in my example here, I have 7x over 14, and my final answer is x over 2. What they've done here is they've actually cancelled the numbers 7 and 14 with their highest common factor. So in this case, the highest common factor is 7. So if I divide both of those numbers by 7, we know that 7 divided by 7 is 1, and 14 divided by 7 is 2. So I've just replaced it from here to there, and we know 7x is the same thing as 7 times x, but because the 7 gets replaced with 1 now, I get 1 times x, which is just x. And then I have the 2 in the denominator, just like that. Now, over here, the second example, I have 7xy, 14 over 14y, okay? So I'm just going to indicate what I think are common factors, okay? So I know the numbers 7 and 14 can be cancelled to 1 to 2. But as you can see here, there's an extra letter here. I have the letter Y. As you can see, there's Y in both the numerator and the denominator. Okay? So what you can do is just cancel them out. So because there's one Y in the numerator and there's one Y in the denominator, it just gets wiped out completely. So what I technically get is the same answer as the first one because all I'm left is X and the number 2. Or 1x, 1 times x, which is just x, and then I have the number 2 in the denominator. Okay, that's all I'm left with. So that means the highest common factor in this case is actually 7y. That's all you're going to do. Okay. Now, these are just some examples I'll go through. So I have 6ab over 18b. Now, in your book or like maybe in your tests, if they're already written as a fraction, that's more commonly seen actually. So you know that this just means divide, okay? So I have 6ab over 18b. I just need to find out what my common factors are. So let's work with the numbers. I have 6 and 18. Is there any number that works well? In this case, I have the number 6 because 6 works. So this now becomes 1. That becomes 3. And then I have a look at the variables here. Do I have any that are similar? I do. So I have b in the numerator and b in the denominator. So that just gets cancelled out immediately. So what I'm technically left with is the number 1, the letter A, and the number 3 in the denominator. So if I were to write that all together, it becomes 1 times A over 3, which equals to A over 3. Okay? Now, in the second question, they don't write it as a fraction. So it's your job to write it as a fraction first. It makes your life a lot easier that way. Okay? So if I write it as a fraction, I get 12a squared b over 3ab. Now, just look at numbers 12 and 3. Can I cancel them out in any way? So in this case, I have 4 to 1 because the highest common factor is 3. 3 times, well, 3 goes into 12 4 times exactly. So that's why I'm just replacing them. I can cancel out b. Yes, most definitely, because there's one b in the numerator and one b in the denominator. That's perfectly fine. The tricky part is this a squared and this a here. Okay. If I were to rewrite this out, this would now become 4 times a over 1 times a. And then the question is, how many a's are there in the numerator? There's 2, but there's 1 a in the denominator. So what I can do is I can actually just cancel out 1 a a piece, depending on based on where they are. And as you can see, I'm left with 4a and 1. Now, if I were to write this out and clean this up, I will have 4a over 1. And another way of writing something over 1 is just the numerator. Okay? That's it. So the answer is 4a. Like terms. So terms with the same pronumerals, variables, and powers. Okay? So that's the key important thing. So the number in front called the coefficient can be different. It doesn't matter what it is. I don't care. All that matters is that they have the same combination of the pronumerals and powers, okay? So as you can see here, I have 3x and 5x. And then the question is, are they like terms? And the answer is yes, because they both have x. Like x is just by itself, and the powers of x is the same, okay? Now I have 2ab and negative 7ab. The answer is yes, because they both have ab in the same power. It's not like it's like ab and then a squared b or something like that. They have to be identical to a fault, okay? So that's something that we'll just have to work on slowly but surely. Now I have 4x squared and negative x squared. The answer is yes, they are like terms because they both have x squared, okay? They both have x squared. That's the important thing. So they may have the same letter, yes, but they also have the same power, okay? Now, something to note, the pronumeral, when you're writing like the pronumerals like with your coefficients, okay? It's always written in alphabetical order. So from A to Z, okay? You must always write it like that. Don't write it in any other way. Now, here are some examples of some non-like terms, okay? So these are like some that may look similar, but they're not really like terms, okay? So I have 2x and 3x squared. So yes, they have x. That's correct. But the thing is, this one has a squared, whereas this one doesn't have a squared right there. Like 2x doesn't have a squared. So 3x has a squared, but 2x doesn't have a squared. It's missing. It doesn't have it. Now I have x, y, and xz. So they may have the same variable x, but as you can see here, I have in the first one I have xy here, and in the second one I have xz here. So they are completely different variables, okay? Do not get it mixed up. And then I have 5a and 5b. Obviously, just looking at the letters themselves, that's A, that's B, they're not the same, okay? So this is a step-by-step guide to collecting like terms, okay? Step one, identify the like terms. So look at each part of the expression, okay? And then you know that terms are separated by the plus or the minus signs already. So what you want to do is just identify which ones are similar, okay? So in my example here, I have 3x plus 2 plus 4x minus 5. It might be best for you to write out what the terms are first. So in this case, I have 3x, I have plus 2, I have plus 4x, and I have minus 5. See how here, how I've like taken the sign in front as well? So I've taken the sign for negative 5, I've taken the sign for plus 4x, I've taken the sign for plus 2. Now, obviously for 3x, there's no sign in front, so you have to assume that this is a positive number here. Okay, so that's technically plus 3x right there. So those are my terms. Step two, group the like terms together. Put together the terms that have the same letter or letters and same powers. Okay, so I have 3x and 4x based on my list here, 3x plus 4x. So we just know that because they both just have x by itself. And then I have plus 2 and negative 5. They're just numbers and they're called constants, okay? Step 3 is to add or subtract the like terms, okay? You can do the math for each group because you've already separated them. So I have 3x plus 4x because as you can see here in step 1, we've identified that both of them are positive, okay? So 3x plus 4x is 7x. And then I have positive 2 minus 5, which equals to negative 3. Now, the final step is to put it back all together in one line. So just based on step 3, I have 7x and I have negative 3. So I put it together, 7x minus 3. Always put the constant terms last, okay? Constant, always last. And then everything else in the front, okay? So like variables and all that kind of stuff, always in the front. So that's pretty much chapter 2b in a nutshell. Please just read the notes carefully. If not, just watch my examples. You'll be fine in this chapter, okay? Algebra's not easy, but it's not that difficult as well. Once you get over that learning curve, you'll actually love it. Enjoy the rest of your day.